Hello and welcome. This will be an introduction to Stata video. This video is intended for students and professionals with limited or no previous experience with Stata. If you've never used the software before, this video is for you. The course or this video focuses on simple data analysis such as reading files, combining and modifying data, and statistical analysis. My goal is that you learn enough about Stata so that you're able to follow the material in my econometrics course and do your own Stata estimations for your classes and projects. Before we proceed, please download the Stata dataset and program from my website so that you can follow along with what I'm doing here in the program. The topics that I will cover is first I will talk about the Stata website and purchasing Stata. Then I will briefly discuss the advantages and disadvantages of Stata. We will talk about the programs, which are the Stata do files with .do extension. This is where your program goes. Then we will talk about data files, the Stata data files, which have a .dat extension or CSV files. And we will also talk about reading data from the internet. Then I will talk about the data editor where the data are imported to. We will also talk about log files where the output is saved. We will talk about importing and exporting data using the insheet command for CSV files and use command for DTA files. We will talk then about summarizing and analyzing data using describe, summarize, tabulate, by, sort, and correlate commands. Next, we will discuss modifying data sets using rename, replace, drop, generate, eGenerate, and xi commands. We will also talk about collapsing and merging data sets, including collapse and merge commands. We will talk briefly about statistical analysis, including t-test and regression. Then I will talk about how to use global statements using the global command. And very importantly for Stata, we will talk about do files, or these are additional commands or procedures for specialty topics. And finally, I will show you how to use help. So I'm on the internet here and I have opened up the Stata website, which is, you can find this by googling Stata, and this is the website that you get to. And in this website you can see how you can explore the capabilities of Stata. So there's a little bit more information on the Stata, different products, related products, and so on. You can also shop and purchase the Stata software and see which one is the appropriate one for you, business, education, or government. They also do international shipping. And finally, there's a lot of resources available for Stata data users, including some listservs and discussion boards. There is a Stata video tutorial and so on that you can take a look at. So please look around the website, and you need to find and download the software first by purchasing it from Stata. Then you can go ahead and learn about Stata by executing the program. So this is the program that I gave you, and it's a .do file, and you can download it from my website. And here is the command window that opens up once you have Stata on your computer and you open it. And I have simultaneously opened the program here and executed it to save time. Now in this video you can bring up the command window, or if you actually look at different windows, you can bring the data editor, you can look at the variables, properties, and so on. But I have simplified the window so that we have more real estate space for the program and the results themselves. So a do file editor, you can open up a new one just by saying new do file editor by clicking there, and you will see a blank file. And from here you can open the program, or I have already opened it up. The way you execute programs is you click on this execute or do window right here. If you execute quietly or run, then you will not see any output in the results window here. Everything would be just in the memory. So I would recommend this. The first thing to notice about Stata is that if it's a green command, it will not be executed. It just runs here, but if you have a star in front of it, then it gets ignored by Stata. The first command that we have here is clear all, so if there's anything in the memory, it gets cleared. And we will use set more off, because if you have a long program, then if you don't have this, you have to click more, and so on in order for all the output to run in front of you. The next thing is how to change directory to the folder with the data files. And in my case, I have recorded everything on my C drive in the folders econometrics/data. And you do that by cd change directory, and then you can view the directory and which files are on there. Then there are 3 different ways in which you can read data files. The first one is importing the data from the internet, and we can use files straight from the internet without ever having them on your computer. You have to give it the precise address. Comma clear means that first you're clearing the memory and then you're reading it, so it's a little bit backwards the way it's written. And use meaning that you're going to put it in the memory. So you can highlight this and do it, and the data will be in the memory. 2 alternative ways are to read this data.dta file, and you use the same command use, and then the file name, I have called it intro_hs0 clear, and that will bring the data in the memory. Or you can import a CSV file by using insheet using, and then you put the name of the data file, comma clear. Now, if you have not specified the directory here to change directory, you need to provide here the full path, and also it could be included in quotation marks to where the files are located. Okay, so in this case, it's a little bit pointless to bring the data 3 different ways since it's exactly the same data set, but I'm just showing you how to do it in 3 different ways so that you can use whichever line you need for your own program. So once you've executed this line, we can go ahead and right here use the data editor so that we can open and look at the data. So we have data on high schools, we have ID numbers, we have whether or not a student is female, and we have their program type, including academic, general, and vocational. And we have the read, write, math, and so on scores for these kids. Okay. So once we've read in the data and we looked at it, we can summarizing using the scribe command. And here is the output under the scribe. And you can see that if there are any labels, you can see which variable is which one, the reading score, writing score, math, and so on. And next thing you can do is summarize the data. And you can either summarize all the variables or just some of the variables if you put the variable names here behind that command. And you can see, for example, you can see an average of the reading, writing score, and math scores in here. You can also take a look at the first few lines of the data by using the command list, and then from gender to read in 110, which means the first 10 lines, and here are the first 10 observations, and you can see this inputted here. So here's a little bit more detailed way to summarize the data. You can summarize, and as I said, you can put the variable names in here, And now you can see only those variables are summarized, and you can put this output in your table. You can also summarize the data if the reading score is greater than or equal to 60. You can summarize if program type equals academic here, and this would be, as you can see, this is now a subsample for the academic program type. Or you can summarize the reading score in detail, and here you can see the different percentiles, smallest, largest values, and more descriptive statistics on the side. You can also summarize the data by using different groups. So here you can use tab program type, and this is the output here. So you have academic, you have different frequencies and percent frequencies. So this is an excellent command tab to use when you have a categorical variable which you should not take a mean of, as we did before. Then you can summarize variables such as read and write by program type. So you're doing by sort first, sorting the data by program type, and then you're summarizing these two variables, and this is the output that we have. For program type academic, this is the means. For general, these are the means, and for program type vocational, these are the means. Next, we can do correlations between variables, and I have put here 3 variables, and these are the results here for correlation. So again, we have high correlations among variables, and we have 1 across the diagonal for correlation. Next one is how to modify the data. You can order the data by using ID listed first and gender being second, so this reorders the variable in the data set. You can label variable, and this is the variable name school type, with type of school, so that it's a little bit easier to track which variable is which. You can rename a variable gender female, because gender 0, 1, you don't know which one is the female or male. That's why we're going to rename it as female, because a 1 means a female, 0 means male. Then you can generate a new variable score, which is the summary of the 3 variables, read, write, and math. You can generate score square, which is score to the power of 2. You can generate a new dummy variable called pass equals 1 if the score is greater than or equal to 150, and replace pass equals 0 if this variable pass is a missing variable. So with these 2 lines, if the score is greater than 150, then you're going to be generating this one. If it's not greater than 150, the first line of code won't be doing anything, so it will be generating a missing value. And that's why you're going to have to come in with the second line and put it equal to 0 if on the first read it was a blank. And notice the double sign here, double equal sign that Stata wants. You can also drop if, say, the reading variable is less than 40, and this drops observations for which this is true, or you can drop the school type variable. And if you just highlight and run line by line, you can look back into the data editor and see the results. So here are the passing score that you have, and it's based on this score. So if the score is greater than 150, it gets a value of 1, otherwise a value of 0. And this is the score squared that we generated. Okay, so the next thing that we can do is we can create a dummy variable based on a categorical variable. And the way to do that is using, first of all, we would sort by program type, and then we will use the command xi, comma, prefix and you put parentheses and then put I dot program type. So the only thing to change is this thing in your code, and you will have variables generated, dummy variables generated on this categorical variable. So when you have 3 categories, usually 2 dummy variables are generated. Looking back into the data editor, here are the 2 variables that are generated here. And if you notice, actually, for the academic, that will be our first program type, all these, the first dummy variable would be equal to 1. And then for general, we would have the second one equal to 1. You see how it changes here. And then when it turns into the vocational, the third dummy variable would be equal to 1. So here's a categorical variable changed into dummy variables. Very useful command. Next, we can generate variables using functions. So for example, we can take the mean of the score variable and call this average score, and we use the eGenerate command. Or you can do average group score, which is the mean for score but by program type. So now we have generated 2 variables. One of them is the average score, which is 162 for everyone in the sample, and the average group score, which is 170 for the first group. Then we have 154 for the second one and 146 for the third one. Okay, so the next thing that we can do is we can run simple t-tests for writing score. And the first t-test is to see if that's significantly different than 50. Here are the results. Here the average is 54, and if you run the test, you can see that actually we have a very small p-value, so our conclusion is that it is indeed different than 50. Next one, you can compare the writing and reading score, and these are their means. This is the difference between them, and the t-test for significant difference is not significant. And then we can compare the writing scores by females, so for males and females. And we have the 2 groups, and then this is the difference. These are the means for them. And then we're looking at significant differences, and again, p-value being very small, we do have significant differences in the reading and writing scores. For next thing to do is regression, and I will put write as the dependent variable and read and female as our independent variables. And again, I'm just using this for example, not that the model makes a lot of sense. So this is how we are running the model. Write is our dependent variable, read and female independent variables. So we have for coefficients, if we have the reading score increases, the writing score increases, and if it's female, then they have higher writing scores. If you would like to include the dummy variable in the regression, you cannot include program type, it's a categorical variable, but you can start the regression. You see like how it's the same command as before, which is here, but you're just adding this new variable i.programType, and you're starting with xi. And this would generate this kind of variable where you have this now is a dummy variable for whether or not the person is in the second program, and this one whether or not a person is in the third one. So you can see that if it's in the third one, they have lower writing scores, but if it's in the second one, this variable isn't significantly different. The coefficient is not significantly different than 0, which means that there are no significant difference between this one and the reference category, which is the first group. The next thing that's very useful to do is to define global variables. And we can define a global list, which would be a Y list, or you can call it anything you want to, and this is the name of the variable that we want to treat it as a Y variable. And then we can have a global X list, and then we can list all the independent variables that we want. So then we can use global variables to summarize the data using summarize, ylist, and xlist. And notice now that these, you have to put a $sign in front of the names that you have given up here in order for it to run. Or you can use regression and then you put ylist and xlist here. And here are the regressions, and as you can see, the summary, even though you call it ylist and xlist, Stata knows the underlying variable and it summarizes the original variables. Likewise, if you say reg and ylist and xlist, you will have exactly the same regression results as before. So you will say, why is this needed? Why can't I just write them up, all the variable names, as we did here? And the reason for that is that in the rest of the course, as I'm giving you programs, I will define these variables ahead of time in the program and then run the program with generic y and x variables. And this way you only have to change the name of the y variable and x variables and the program will run for you. Because I noticed that when they're novices, it's kind of hard for them to realize which one is a variable and which one is a command. So this way it's very easy not to make mistakes. Next thing that I'd like to show you is how to use do files. And in this case we can download outreg for paper ready tables. And the way to do that, you go to help and then search and you can put outreg here. And you can scroll down and download it from here. So just click on here and then click to install, and that would install the outreg on your computer. Now this is one of the best things about Stata, is that not many of the packages are loaded directly in here, but if there are any user-defined do files, you can download them and run them, and usually they have the latest econometric techniques that you can use for your analysis. And then you can use it using outreg and using regressions output, and you can store the output that we had here in a text file. Okay, so the very final thing to show you is how to use log files, and I have skipped this, but you can create a log file to store output, and if you remove the star in front of it, this line will now get executed, and you can say log using, and this is creating a file name, which is a text file, and comma text replace, and then at the end we would have log close. So now if we run the whole program here, we would have generated a data file called, we would generate a stata_output text file on your hard drive where this output is stored. So for example, I use this a lot by running the program myself and then giving the output to other people who are working with me but may not have Stata on their computer to run the program, so that they could view the output at any time. Okay, so this is generally how to run programs in Stata. The help is very useful. You can search different commands here. Now, if you don't know how to do things, the slow way to do it, you can go with statistics and say linear model and kind of look around, and you can estimate a linear regression, and you could put the dependent variable here, the reading and the writing scores as independent variables, and then click submit, and this way it would execute the commands a little bit slower, and then it will also generate the code for you that you can later use in your program to save and then use it in the future. So this was a very quick introduction to Stata. Thank you for watching, and please come back and watch more videos. Thank you.